Hello, Ma. Good morning. Next, next topic is Introduction to Database Design. So, what is database? Database is nothing but collection of facts in one platform. And what is the design for it? So, let's see this records. So there is let's see this relation. Here, student ID, name, GPA, major, and address. These are the names of the fields. Student ID is so and so roll number, name is Jones, and GPA is 4. So major is what is the major subjects are there? Economics and the address part. Here, GPA, student ID, name, major and address are called, this vertical column is called a field. The horizontal line is called a record. So these are the basic funda for any database table. The next topic goes to the ER model. What is ER model? ER model stands for Entity Relationship Model. It is a high-level data model. This model is used to define the data elements and relationship for the specified system. ER model is like a blueprint for the DBMS. It develops a conceptual design for the database. It also develops a very simple and easy to design view of data. In ER modeling, the database structure is portrayed as a diagram called the entity relationship diagram. So, entity means nothing but a facts. Relation among the relation of entities is designed with the help of a model that is called ER model. For example, suppose we design a school database. In this school database, the student will be the entity, which attributes like address, name, ID, age, etc. So these all are nothing but the attributes. Attributes are nothing but characteristics. The address can be another entity with have attributes like the city, street name, pin code, etc. And there will be a relationship between them. Let's see a small example in the, for this example, let's see how the diagram is represented. Here the student is there, address, name, age, and ID. Components of the ER model. So ER components are basically three types: entity, attribute, and relationship. So entity, again there are two types: strong entity and weak entity. Strong entity is by default written as entity only. Attributes like key attribute, composite attribute, multi-valued attribute, derived attributes. Next, relationship: one-to-one relationship, one-to-many relationship, many-to-one relationship, many-to-many relationship. Let's see what is entity. Entity may be any object, class, person, or place. So we have learned in our childhood, we have played the game like name, place, animal, thing. So we can tell that is entity. In the ER diagram, the entity can be represented as rectangle. Consider an organization, for example, manager, product, employee, department, etc., can be taken as an entity. For example, employee works under for a department. Under the department, many employees exist. Weak entity. The weak entity that depends on another entity. So that is called a weak entity. The weak entity does not contain any key attribute of its own. So the weak entity is represented by a double rectangle, where a strong entity can be represented by a single rectangle. Next comes the attributes as the characteristics of entity. The attributes of is used to describe the property of the entity. Eclipse is used or oval. Eclipse or oval is used to represent the attribute. For example, ID, age, contact number, name, etc. can be the attributes of the student. The key attribute is represented by the underline. The key attribute used to represent the name characteristic of the entity. It represents the primary key. The key attribute is represented by the ellipse with the text underlined. The next type of entity is the composite entity. The attribute that composed of many other attributes is known as composite attribute. The composite attribute represented by the eclipse ellipse, and those ellipses are connected with an ellipse. So there is a root ellipse which is again having three child ellipses. For example, name. Name is again divided into first name, middle name, and last name. So this is nothing but a composite attribute. Next, multi-valued attributes. The attribute can have one or more value. These attributes are known as multi-valued attributes. The double oval is used to represent the multi-valued attributes. The student can have one or more phone number. The student can have one or more teachers. A parent can have one or more children. Derived attributes. The attributes that can be derived from another attribute is known as derived attribute. It can be represented by the dashed ellipses like this, what is shown in the figure. For example, the person's age changes over time and can be derived from the date of birth. So the age can be calculated from the date of birth. Next topic is the relationship. So relationship is used to describe the relation between entities. Diamond or rhombus is used to present the relationship. Types of relationship is 1-to-1. So we have to represent like 1, here 1, input 1, output 1. For example, when only one instance of the entity is associated with the relationship, then it is known as 1-to-1. A female can marry only one male, and a male can marry only one female. This is an example. So this is 1-to-1 relationship. The next is one-to-many. When only one instance of entity on the left and more than one instance of the entity on the right associate with the relationship, then this is known as one-to-many relationship. For example, scientists can invent many inventions. A teacher can have many students, but the invention is done by only one specific scientist. Many to one. When more than one instance of the entity on the left and only one instance of the entity on the right associate with the relationship, then it is known as many to one relationship. For example, student enrolls for only one course, but the course can have many students. So many women marry one man is called polygamy. Many to many relationship, and more than one instance of the entity on the left and more than one instance of the entity on the right associates with the relationship, then it is known as many to many relationship. For example, employees can assign by many projects and the project can have many employees. So basically, this ER is nothing but the pictorial representation of a state. ER sets. Now, notation of ER diagram. Database can be represented using the notations ER diagram. Many notations are used to express the cardinality. These notations are as follows. For example, this is nothing but 1-to-1. This is representation is like this. Next, one-to-many. So one with many output. This is many. Next, many, one or many. Next, one and only one. And 0 or 1. Or many or 0. Mapping constraint. A mapping constraint is a data constraint that represents the number of entities in which another entity can be related via the relationship set. So, what I want to explain is a mapping is nothing but mapping constraint is nothing but a data constraint that tells the number of entities in which another entity can be related via relationship set. It is the most useful in describing the relationship set that involve more than two entities. For binary relationship set R on the entities set A and B, there are four possible mapping cardinalities. They are one to many, that is 1:1, one to many, 1:m, where m stands for many, many to one, m is to one, many to many is m is to m, 1:1. In 1:1 mapping, the entity in E1 is associated with at most one entity in E2, and an entity in E2 is associated with the most one entity in E1. One to many. In one to many mapping, an entity in E1 is associated with any number of entities in E2, and the entity of E2 is associated with at most one entity of E1, many to one. The one to many mapping, an entity in E1 is associated with at most one entity in E2, and an entity in E2 is associated with any number of entities in E1. Many to many. The in many to many mapping, an entity in E1 is associated with any number of entities in E2, and the entity in E2 is vice versa, is associated with any number of entities in V1. Next, the topic is keys. Keys play an important role in the relational database. So it is used to uniquely identify any record or row of the data from the table. It is also used to establish and identify relationships between tables. For example, in student table, ID is used as key because it is unique from each student. In person table, passport number, license number, some student number are keys since they are unique for each person. So the keys for the student ID, name, address, and course. Which is unique. ID is unique for a person, some name, date of birth, passport number, license number, and etc. These three lines introduce which is unique. Types of keys. The types of keys can be divided or can be categorized like primary key, candidate key, super key, foreign key, and unique key. Primary key. It is the first key which is used to identify only and only one instance of the entity uniquely. An entity can contain multiple keys as we saw in person table. The key which is not suitable from those list becomes the primary key. In the employee table, ID can be a primary key since it is unique from each employee. In the employee table, we can even select license number and passport number as primary key since they are also unique. For each entity, selection of the primary key is based on the requirements of the developers and their utilization in the table. For example, employee table as employee ID, name, address, passport number, license number, some SSN number. Among all these, we select employee ID as the primary key, which is accessible and can be done transaction all the transaction of the table with the help of this unique key called employee ID as primary key. The candidate key is attributes or set of attributes which are unique, identified a tuple. The remaining attributes except the primary key are considered as candidate key. The candidate keys are as strong as the primary key, so which are unique. The remaining part apart from primary key is called the candidate key. For example, in the employee table, ID is the best suited for as primary key. The rest of the attributes like SSN, passport number, and the license number can be considered as candidate key. Candidate key, for example, is represented by the green letters. For example, employee is a table where employee ID is called the primary key, name and address, and the remaining green letters like passport, license number, SSN number is all or nothing but candidate keys. Next is the super key, a set of attributes which are unique identified a tuple. Super key is a superset of the candidate key. For example, in the above employee table, for employee ID, employee name, the name of two employees can be same, but the IDs cannot be same, and the combination can also be a key. The super key could be an employee ID, comma, employee name, etc. Next, the foreign key. The foreign keys are the common of the table which is used to point to the primary key of another table. In the company, every employee works in a specific department, and the employee and the department are two different entities. So we cannot store the information of the department in the employee table. That is why we link these two tables through the help of primary key of the table. We add the primary key of the department table as department ID as a new attribute in the employee table. Now the employee table department ID is the foreign key and both the tables are related to each other. Let's see this diagram. There is two tables called employee table and the department table. Here, employee ID is a primary key. Here, department ID is also a primary key for the department table. But this department number is a foreign for the employee table. Relation types and relation set. The next topic is relation types and the relation set. A relationship type represents the association between relationship and the entity types. For example, enroll in a relationship type that exists between entity type, student and course. In ER diagram, relationship type is represented by the diamond and connected by the entity with lines. Let's see here. Here, student is enrolled in a course. So student is entity, course is entity, which is represented by the rectangle, and enrolled in is the relationship. Let's see some of the set theory. A set of relationships of the same type is called relationship set. The following relationship set depicts S1 is enrolled in C2, S2 is enrolled in C1, and S3 is enrolled in C3. Degree of relationship set. The number of different entities that participate in the relationship set is called the degree of relationship set. Unary relationship, when there is only one relationship entity set participating in a relation. The relationship is called a unary relationship. For example, one person is marrying to one person. So one person is marrying to one person. One person is married to one person. It's the representation in the ER model or with the help of the ER diagram. Next, binary relationship. When there are two entities set participating in a relation. The relationship is called a binary relationship. Two entities are participating, so it is called binary. For example, student is enrolled in a course. Next, n-ary relationship. When there is an entity set participating relationship, then it is called n-ary relationship. Next comes to cardinality. The number of times entity of the entity set participates in relationship set is known as cardinality. Cardinality can be of different types. One to one, where only each entity set can take part only once in the relationship. The cardinality is 1 to 1. Let us assume that a male can marry to one female and one female can marry to one male. So the relationship will be 1 to 1. A male can marry one female. A female can marry only one male. So it is 1 to 1. So, so this is also the Cartesian representation of 1 to 1. Next, many to one. When entities of one entity set can take part only once in the relationship set, and entities in the other entity set can take part more than once in the relationship set, cardinality is many to one. Let us assume that the student can take only one course, but one course can be taken by many students. So the cardinality will be n to 1. It means that one course they can be n students, but for one student they can be only one course. For example, with the help of ER diagram representation is student is enrolled in one course. And this is nothing but the set representation, initial set representation. Many to many. When entities in all entities set can take part more than once, relationship cardinality is many to many. Let us assume that the student can take more than one course and one course can be taken by many students. So the relationship will be many to many. For example, student enroll, m number of students are enrolled to n courses. The relationship set is as follows. Participation constraints. Participating constraints is applied to the entity participating in the relationship set. Total participation and partial participation. Each entity in the entity set must participate in the relationship if each student must enroll in a course. The participation of the student will be total. Total participation is shown by double lines in the ER diagram. Partial representation. The entity in the entity set may or may not participate in the relationship. It some courses are not enrolled by any of the students, that the participation of the course will be partial. The diagram depicts the enrolled in relationship set with the student. The entity set having total participation and our course entity set having partial participation. So the representation of this is represented like this. M students with N courses. So represented in a double line and this in a single line. So let's again come back to this. The total participation is each entity in the entity set must participate in the relationship. If each student must enroll in a course, the participation of the student will be total. Total part is done by double line. So a double line is called the total participation. This is a relationship set. Next, binary relationship. When the two entities set participate in a the relationship is called the binary relationship. For example, student is enrolled in courses. Additional feature of ER model. So the next topic is additional feature of ER model. So the additional features can be generalization is one of the additional feature. So let's see what the generalization means. Is the bottom up approach. Bottom is down to up approach, in which two or more entities of lower levels combine to form the higher level entities if they have the same attribute in common. In generalization, an entity of higher level can combine with entities of the lower level to form a multiple higher level of entity. A person can be a faculty, a person can be also a student. Generalization is more than like subclasses and superclasses system, but the only difference is the approach. Generalization is used the bottom up approach. The generalization entity is combined to form more generalized entity. That is, subclasses are combined to make a superclass. Faculty and students entities can be generalized and create a higher level entity person. The next one is the specialization of the additional feature of the ER model. So first one is generalization, next is specialization. The specialization is a top-down approach and it is opposite of generalization. In specialization, One higher level entity can have the broken down into small pieces. Specialization is used to identify the subset of the entity set that shares some distribution characteristics. For example, employee is a tester and also a developer. Normally, the superclass is defined first and the subclass is defined. The related attributes are defined next and the relationship set is then added. For example, in employee management system, employee entity can be specialized as tester or developer based on what role they play in the company. Next one is the aggregation. This is also one of the additional feature of the ER model. First, we have discussed about realization. Next up, generalization, and the third one is aggregation. In aggregation, the relation between two entities is treated as a single entity. The aggregation relationship with its corresponding entity is aggregated into a higher level entity. For example, candidate offers or college is offering many courses. So this college offering and courses, these three is represented as one entity. The combination of all these three to represent as one entity is called aggregation. Reduction of ER diagram to table. So the second phase for the relational databases, the first is the 2D representation. The second is we have to change it into the table. The database can be represented using the notation, and these notations can be reduced to the collection of tables in the database. Every entity set in relationship set can be represented in a tabular form. The example for the EN diagram is shown in the below slide. Here the student as address. The address can be divided into the state and the pin code. Or the city, street, and some door number or something like this. Next, the student name. Student ID is the keyword and the course ID. The student is ages can be derived from date of birth and Hobbies can be can have more or one or two hobbies. A student can attend the courses. The courses again divided as course ID and course name. The lecturer teaches the student. The lecturer ID, lecturer name, and the lecturer course. The lecturer teaches the subjects, the subject ID, subject name, and the subject topic. And this can be relationship with the course. The next topic coming to the conceptual design with ER model. This is the last topic of this unit. So the points to be observed here is how can we build the conceptual design model? How can we recognize the entity types? How can we recognize the entity type relationships? Identify and connect attributes with entity or relationship types, determine attribute domains, determine candidate or primary key or alternative key attributes, consider the use of improved modeling concepts, check model for redundancy, validate the conceptual model against user transaction, review the conceptual data model with users. Building the conceptual model. The first step for the conceptual database design is to build one or more conceptual data replica of the data requirements of the enterprise. The conceptual data model comprises of the following elements like entity types, types of relationship, the attributes and the various attribute domains, primary key or alternative keys, integrity constants. The conceptual data model is maintained by documentation, including ER diagram and the diagram and the data dictionary, which is produced throughout the development of the model. There are many points, some points for converting ER diagram into a table. ER type becomes a table. In the given ER diagram, lecturer, student, subject, and course form the individual tables. All single valued attributes become a column for the table. In the student entity, student name and student ID from the column of the student table. Similarly, course name and the course ID form the column of the course table and so on. Key attributes for the entity table deposited by a primary key. A given ER diagram, course ID, student ID, subject ID, lecturer ID can be a key attributes of the entity. Next, multi-valued attribute represented by a separate table. In a student table, a hobby is a multi-valued attributes that it can be more than one hobby that represent multi-values in a single column of the student table. Hence, we create a table student hobby with Column name, student ID and hobby. Using both the column, we create a composite key. Composite attribute represented by components. In the given ER diagram, student address is a composite attribute. It contains city, pin code, door number, street, and state. In the student table, these attributes can merge into an individual column. The next one is the derived attribute are not considered in the table because the student table age is a derived attribute which is coming from the date of birth and the current date. Like this, when we calculate the difference, we get the age. Using these rules, you can convert the ER diagram into tables and columns and assign mapping between the tables. The table structure for the given ER diagram is as below. The student is having attributes like student ID, name, date of birth, door number, street, city, state, pin code, and course ID. Lecturer is having lecturer ID, name, and course ID. Now subject entity is having subject ID, subject name, and lecturer ID. Course table is having course ID and course name. A student and hobbies is again represented by a table called student ID and hobbies. This is the end of the unit 1. Thank you.